Okay, so let's consider the context where a lab is running a viral test in order to determine whether a person is currently infected with a disease. We'll use COVID-19. And so here, the claims that they would be testing with each other is either the person is infected or the person is not infected. So this is why it's a good scenario for to frame in the logical context of a hypothesis test, since we have two competing claims. And we want to think about what are the type 1 and type 2 errors going to tell us about this scenario. And so first let's consider the hypotheses. So HO is the boring claim, which in this case would be that the person is not infected with COVID-19. And the alternative would be the interesting result, which in this case would be that the person is infected with COVID-19. So we need to think about what the hypotheses are before we can consider what type 1 and type 2 errors are. Okay, so let's recall what a type 1 error is. This is the false positive. So this is when we falsely get a significant test result. So this is when we falsely reject the null hypothesis when it's true. So in this example, falsely rejecting the null hypothesis is if we were to reject the null hypothesis, then we're rejecting the claim that a person is not infected. So in other words, what we're saying is a person is infected when in fact they are not. That was a wrong conclusion. So that would be, again, the situation where we incorrectly tell someone that they are infected when in fact they're not. And now let's think about what a type 2 error would tell us in this context. Okay, and so for the type 2 error, this is the situation when we fail to reject the null hypothesis when in fact HO is not true. So in fact, we should have rejected it. So this is like a false negative. We falsely determine the test is not significant when in fact it is significant and we should reject the null hypothesis. So in this case, failing to reject HO would mean that we're getting an inconclusive test result. So in other words, we're not telling the person that they are infected when in fact they are. So we can maybe summarize this by not telling a person they are infected when in fact we know that they, or when they are infected. That's like getting a false negative test result. And so depending on the context, it's not good when we make errors in general, but there's some balance between the type 1 and the type 2 error. So depending on the context, we might want to avoid one error more so than the other. And so if we think about this context and comparing these two errors, well, a type 1 error telling a person that they are infected when in fact they're not infected, yeah, that's not very great for the person. They might have to quarantine themselves when in fact there was no need to quarantine themselves. So here we can say this maybe is a little bit annoying for the person who has to now quarantine themselves. A type 2 error, that might result in somebody who is infected thinking that they're not infected and then going out and behaving as if they weren't infected. And this could have really, really bad consequences in that they start infecting other people. So in this situation, we would really want to focus on reducing type 2 errors as much as possible. And if that leads to some type 1 errors, that's not the end of the world. Okay, the downside of that is there were some people that have been told they're infected when they're not. And that's a lot better alternative than having a whole bunch of people who've been told they're not infected going out and actually infecting the general population. So let's take a look at another example of analyzing what type 1 and type 2 errors are in the context of a problem.